All right, so we want to create a geometric sequence and find the 8th term. So every time we have to start off with our original equation, an equals a1 times r to the n minus 1. We see that a1, that's our first term, is 1, so we can plug that in. Our r is our rate, so what are we multiplying by? So from here to here, I'm multiplying by -5, -5, and -5. So that means my rate would be -5, n minus 1 equals an. All right, now I need to find the 8th term. So that means an equals 1 times -5 to the 8 minus 1. So that means 1 times -5 to the 7th power. And my answer, this should be an 8 here. My answer for A8 equals -78,125. So my two answers would have to be my original equation and my A8. Now, what if I give you a term in the geometric sequence in the common ratio and you have to find the formula? So this is a little bit step above. So instead of me giving you A1, you're going to have to find it given the rate. So I would say an equals a1 times my rate to n minus 1. And I'm giving you a6. So that means 64 equals a1 times 2. Our n is 6. So 6 minus 1, which is 5. So 2 to the 5th power gives me 32. 64 divided by 32 gives me a1 as 2. So my formula would be a to the n, a sub n, equals 2 times 2 to the n minus 1. And that would be my formula. Now these problems are a little bit different. I didn't give you the rate and I didn't give you the first term. So you're going to have to figure out what the rate is. So what you do first is you take the one that's bigger for like the term that's the biggest term. So we look down here, 5 is bigger than 3, so we'll do 324 divided by 36 and get 9. To go from 5 to 3, that's 2 terms, so that's telling us to square root 9. And that gives me 3. So that's my rate. So an equals a1 times 3 to the n minus 1. Now we have to find a1, so we're going to do what we did on the last slide. So 324 equals a1 times 3. Your n is 5, so to the 4th power. 3 to the 4th power equals 81. 324 divided by 81 gives me 4 for a1. So an equals 4 times 3 to the n minus 1 would be my formula. And then I need to find a12. So a12 equals 4 times 3 n minus 1. So 12 minus 1 is 11. So 3 to the 11th power times 4 means a12 equals 708,588. And this is the way you're going to write it. You can't write a sub n because this is not for all of the n values. It's just for 12. So you have to have proper writing for this. And now let's look at the next one because it's slightly different. So once again, we're going to take the 6 one and divide it by the 3. So -128 divided by -16 gives me 8. To go from 6 to 3, that's 3 away. So I'm going to cube root it. So the cube root of 8 is 2. So that means my r is 2. So an equals a1 times 2 to the n minus 1. So a6 means -128 equals a1 times 2. 6 minus 1 is 5. 2 to the 5th gives me 32. So -128 divided by 32 gives me -4. So a1 equals -4. So my formula is an equals -4 times 2 to the n minus 1. Now we have to find a12 again. So a12 equals -4 times 2, n minus 1 is 11. So 2 to the 11th times -4 gives me negative 8,192. Negative 8,192. So what is important here is to see from 5 to 3, we're going to square root it. 6 to 3, we're going to cube root. So the amount of difference is what you use. So there's that imaginary 2 here. Square root it, cube root it. Now we're going to try and put everything together, and we're going to solve some exponential equations. So we went through all the processes, but instead not solving, we went through all these different processes, but we haven't solved fully yet. So let's say we have the same bases. Whenever we get to the same bases, we could just take the exponents and set them equal to each other. So 3x equals 2x plus 3. Solve for x, and we get x equals 3. So that's all you would have to do if I gave you the like bases. Of course, we're in the honors level class, so I'm not going to give you the like bases. You're going to have to get it into a like base. So for a question like this, we look, 2 can't be written as anything to some power. However, 4 can be. So we want to get it into the base of 2. So 4 can be written as 2 squared. So we would put that just like that. Then we have to remember our exponent rules. 2 times x would be our rule because we're raised to the x power. And now, just like we did up here, we're going to set them equal to each other. So our x is negative 3. So let's try some more. So we look, all right, 9 is the smaller of the one, so let's try to make 9 become 27 with some power. And you're thinking, we can't do that. 9 to the second power is 81. So we have to find a number they have in common that we can raise to become that number. So 9 and 27 have 3 in common. So 9 can be written as 3 squared, and 27 can be written as 3 cubed. So then we multiply together. We have to remember, we are multiplying the term x by the term x plus 1, not just by the term x. So we're going to have to distribute to both quantities and set equal to each other now that we have the same base. So when we solve that, we get x is 4. For the next problem, it's a little bit different because we now have something in a denominator. We have to go think back to our exponent rules where if there's something in the denominator, that means to the negative power. So 1/2 is the same as 2 to the negative first power. And now that we have that base of 2, we're going to want to find the base for the other one, which you see on the screen. 4 is 2 squared. Now we multiply and we get 2 to the negative x equals 2 squared. Now that we have the same base, we don't have anything raised to any power like up here, we're going to set equal. And we get x as negative 2. The same thing goes for the next problem. 1 over 64, we know that's the same as 1 over 4 to the third power, but once again, we need them to be on the same level. We can't have one in the denominator, one in the numerator. So we're going to bring that up, and that gives me 4 to the negative third power. Now that we have the same bases, we're going to set equal to each other, and we get x as negative 4. You know, you guys tried some problems after this, so if you want to retry them, you totally can, and see if you got your answers correct. It's the same steps every time. You just need to figure out what you're multiplying by, or what your base should be to raise to some power. All right, so now we're going to combine everything that we just did. So for the first part, I feel like this is one of the easier problems. I would ignore the second bullet for now because that might give us some confusion. Let's just look at the first one. So if I'm asking you to give me a geometric sequence with A1 is 5, R is 2, you're going to create something like AN equals A1, which is 5, the rate, which is 2, to the n minus 1. Not bad compared to what we've been doing. So that would answer that question. But now this is a little bit different. We want to find AN. We want to find N if AN is 640. So it's saying AN is 640. So we're going to do 640 equals 5 times 2 to the n minus 1. Oop. Now we divide both sides by 5. You guys solve for exponential growth and decay. To solve, we would divide by the number in front of the base raised to the exponent. So we get 128 equals 2 to the n minus 1 power. But then you're like, what is 128 in terms of like 2 to some power? And sometimes that is hard to see. Sometimes it's easy. Sometimes you're like, I just don't know. So what you have to do now is use our logs that we did for exponential growth and decay as well. So I would take the log of 128 and set it equal to n minus 1 log of 2. We have to remember our log rules where our exponent comes out into the out in front. So now we're going to divide by log of 2, and this goes away. And let's put that in our calculator. Log of 128 divided by log of 2 gives me 7. So 7 equals n minus 1. Add 1 to both sides, we get n is 8. If we did it without logs and we knew that 128 is 2 to the 7th power, we could have done that. Then we would set 7 equal to n minus 1, just like we did here. And we would get n is 8. So either way, you get the same answer. Sometimes it's just not as clear. So let's try one like this. So this was a little bit step above. Instead of me giving you A1, you're going to have to find A1. This is something you would see on the quiz where I'm going to make you figure out the formula without giving you A1, and then you're going to have to apply it to another problem. So what you want to do first is set up the equations. We have AN equals A1 times 3 to the n minus 1. We don't know what A1 is, but we know that A2 is 6. 2 minus 1 is 1. So 6 divided by 3 is 2. So my formula is AN equals 2 times 3 to the n minus 1. All right, we found my geometric sequence. Now we're going to need to find n. So we're given that AN equals 39,366 equals 2 times 3 to the n minus 1. Divide by 2. We get 19,683 equals 3 to the n minus 1. Now, I personally don't know what 3 to what power equals 19,683, and it might take you some time to plug that into the calculator. So we might as well just use our logs. Equals n minus 1 log of 3. And let's put that in our calculator. So log of that big number divided by log of 3 gives me 9. So 9 equals n minus 1, so my n is 10. So the answers to this problem would be the first one up here, our formula, and n equals 10. So if you guys have any questions between now and Wednesday, please email me, and have a great rest of the day.